Pretty nice. All right. Quadratics, why there's two forms. So again, I'm going to be gone. I just want to kind of do some review with you guys before I give you a little assignment, and then you're going to do a little exit ticket at the end of class. So what do we know about quadratics? We know that their graph is a U-shape. It's called a parabola. We know that if the a is positive, it goes up. If the a is negative, it goes down. We also have a standard form, ax squared plus bx plus c. And using that standard form, we can find our axis symmetry, x equals negative b over 2a. We can also find the vertex. We also talked about vertex form last time, and I had a lot of you guys do this where you stood up and we wrote down, hey, what's the vertex? I went right 2 up 3, so that's vertex form. Now, the whole point of having two forms is sometimes one's easier than the other depending on what we're doing. So if you have standard form, it is very easy to factor, which is very easy to find the x-intercepts. I think that's the major advantage for standard form. We can find the vertex and the x-symmetry. It just takes some work. It's a little bit harder than the vertex form. But it is very easy to find the y-intercept. So this is kind of the new concept today that I was going to introduce. So if I have 2x squared plus 4x minus 6, okay, a y-intercept is going to be 0 comma something, right? So here's an example of a bunch of them. Notice the x value is always 0. So saying that, what am I probably going to plug in for x? Well, I'm going to plug in 0. So I'm going to plug in 0 for these x's. Notice these are going to become 0. The only thing that's left is negative 6. So what's nice about standard form is that your c is your y-intercept. Vertex form, some advantages to it. It's really easy to find the vertex, right? We kind of, again, just doing the same example from above. We talked about how that's the vertex, which is your axis symmetry. X equals 2 is the x value. It is easy to graph because you just make a table, and what's what we're going to work on today. This is kind of the new thing for today. And we can also change it to standard form. So say you absolutely hate vertex form, you can go back to standard form, and you could still solve the problems. So let's kind of review here. Let's do this problem. Let's find the axis symmetry from this problem. So I'm going to label my A, my B, and my C. I'm going to do x equals negative b over 2a. So x equals negative 4 over 2 times 2, which is negative 4 over 4, which is negative 1. So then I'm going to take that negative 1, I'm going to plug it in to help me find the rest of my vertex. 2 parentheses negative 1 squared plus 4 times negative 1 plus 3. 2 minus 4 would be negative 2. Negative 2 plus 3 would be 1, I believe. Negative 1, 1. Yep, so my vertex is going to be negative 1, 1. Remember, just seeing on some errors that I saw in 3b and 4b, just make sure you're writing it as a point, right? It's not going to just be just 1, right? It's going to be negative 1 comma 1. So then we also want to find the y-intercepts. So if we want to find the y-intercepts, that just means I'm going to plug in 0 instead of whatever my x value is, and I'm going to get 0 comma 3. So the nice thing is your c is the y-intercept. So the c is the y-intercept. And then if you wanted to find some other points, right, we can always find the x-intercepts. I feel like that's super important. This is a factoring problem. And on this factoring problem, you have to do the AC method, and then we would do that, but we're not going to do that for the sake of this, because we typically only want to factor on quadratics when it's easy factoring. If it's like this, we'll probably just plug in a value. All right, so that's the two big things that I wanted to kind of emphasize. We'll talk about making a table on the vertex form, but really you want to put your vertex in the middle, and then you want to find values to the left and to the right of your vertex. Now what's nice about this is, we kind of talked about this, whatever happens on one side happens on the other. So like if this is 3, that means this is also going to be 3, right? So you can find 2 points just to graph it that way. So if I gave you one more, kind of tried to trick you a little bit on this one. There is no c, which is fine. That just means your y-intercept in this case is going to be 0, 0, because there is no c at the end. So that means my c is 0. If there's nothing there, that means your c in that case, like I said, is 0. Like say there's no b, that means your b is 0, whatever it is in that case. So we're going to do 8 over 2 times 1, which is 4. We're going to plug in that 4 for our vertex. So I'm going to get 4 comma, I think it's negative 16, I believe. And so that's what you get for your vertex there. Again, we could do the same thing where we graph it. We could do an XY table. What goes in the middle is your vertex, and then you kind of build around it from there. So 3, 2, 1, right, 5, 6, 7. And we'll talk about this here in vertex form, but I wanted you to get in the habit of making this table where I have the vertex in the middle, and then we'll find some other y values. So let's do this. It says graph the following, name the vertex and one other set of points. So easy thing is we got to recognize first off, hey, what form is this in? Well, it's in vertex form. So that means I'm going to go right 4 up 5. So my vertex, really, really easy, is 4 comma 5. Now here is the new stuff in the vertex form. We still put the vertex in the middle, but to find two other points, like the easiest way to do this is to create values that are close to the x value of 4. So 2 and 3, 5 and 6. Now, again, I told you what's nice about a parabola. This one, because it's 1 away from the vertex, is the same as this one. So the yellows will be the same answer. The blues will be the same answer. So you really only have to plug in one of those things. Now notice, this is an x value. Is there an x that I can plug it into? Yes, so I'm going to plug in that x, right? So we're going to type that into our calculator. It's going to do the work for us. I kind of want everybody to grab their calculator and make sure you can type this in correctly. You should do 2, 5, parentheses 5 minus 4, square it, and then plus 5. And you should get 7. So again, we plugged in 5, we got 7. What's nice is that 3 is also going to be 7. You could plug it in and check it, but I'm just telling you, and we'll probably do that in class if I was there. But what's nice is we don't have to. So 6 minus 4, I'm going to put this 2 out here. So now we're going to plug in 6. We do the same thing. We type it into our calculator, 6 minus 4. You square it, you add 5. You get 13 on that one. So we'll put 13, and again, whatever it's, that one is going to be that one as well. So that's the nice thing about it, is you don't really have to do a whole lot. Now, we could convert it to standard form, which is what we're going to do on the next thing, but you really don't have to. So we just find the vertex, right? Boom. Put that vertex in the middle of our XY table. Pick an X value that's close to -5, and then you just plug it in. So I'm going to plug in, this time I'm going to plug in -4. So I'm going to write it out. I'll do it in purple again. We'll say y equals -3, -4, plus 5 squared, minus 54. You get -57. Again, whatever happens here is going to happen here. Now, I'm not going to plug in -3 for the sake of the time of the video, but you guys can do that if you need to. So just realize we can still plot points in vertex form, even if it's a really big number, whatever it may be. And then finally, what we're going to do is we're going to turn these vertex forms into standard forms. So the first thing I want to start with is use a PEMDAS x minus 4 squared. We took a test over this. Remember, x minus 4 squared means x minus 4 times x minus 4. So you might have to do the box method, x -4, x -4. You get x squared, -4x, -4x, and 16. So this becomes x squared minus 8x plus 16 plus 5. So what I did is I FOILed. We've done that before. We just multiplied there. Now I'm going to distribute that 2 to everything in here. So I'm going to get 2x squared minus 16x plus 32 plus 5. Don't forget about that plus 5 at the end. A lot of people tend to forget that thing there. And then I'm going to combine like terms, and voila, we have a standard form equation. So I want you to go ahead and try this one. Maybe we could pause the video here, and you could try it by yourself. But you'll do x plus 5 minus 54. I'm going to distribute that -3. And that's what I get. So with all these skills today, what we're going to do is we're going to have a little quizzes review. So I want you to go do that quizzes review. If you can get at least an 80% on that, that's huge, because that means you know what you're doing. And you're going to do a little exit ticket at the end where you're going to graph some 2 parabolas. One's in standard form, one's in vertex form. So think about if it's in standard form, what you need to find. You need to find the vertex and the x-intercepts or the y-intercept. And then if it's in vertex form, you probably need to find the vertex and then find another point that you can plot. Okay, so with that being said, I know I was gone, but we'll review this on Friday as well. We'll kind of talk some graphing with vertex form. Try your best on the exit ticket, and the sub will collect those. You have to turn those in before the bell rings, and that is all we're doing today.